everybody. I am Byron. I am Frenchie. I'm Morgan. Bye, brother. I am Hans. And I am Olivia. Tweet, 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 tweet. And today, we're going to be learning about how to multiply by fractions and decimals less than 1. Ooh. Fractions and decimals less than 1, you say? Well, we could recall that by looking at this number line. All of these fractions and decimals are less than 1, especially this one, because it's just 0. But this is exactly 1. So, what we're really going to focus about today is to multiply by fractions and decimals over here in the beginning, the middle, and only some of the end of the number line, because the absolute end brings us to 1. So, we are just going to focus on these. But how do we do that exactly? Well, there are a few examples of how to do this. Example 1 shows that you could multiply decimals less than 1 by any whole number simply by multiplying the decimals by how many ones the whole number has. For example, A shows that 0.1 times 4 equals 0.1 times 1 plus 1 plus 1 plus 1, because 1 plus 1 plus 1 plus 1 is 4. So 0.1 times 4 is equivalent to 0.1 times 1 plus 1 plus 1 plus 1. That makes them so that they could transition into 4 0.1s. That makes 0.1 plus 0.1 plus 0.1 plus 0.1, because 0.1 times 1 is 0.1, obviously. And all of those 0.1s add up to 0.4, or simply 4 divided by 10. And if we were to simplify that, 4 divided by 2 is 2, 10 divided by 2 is 5, 4/10 would be 2/5, or 2 divided by 5. That would be very useful. You could also do the same thing for fractions. 1/10 times 4 equals 1/10 times 1 plus 1 plus 1 plus 1, which equals 1/10 plus 1/10 plus 1/10 plus 1/10, because 1/10 times 1 is 1/10. Those 1/10s add up to 4/10, which is also 4 divided by 10, or 2 divided by 5. Because if we simplify that one, 4 divided by 2 is 2, 10 divided by 2 is 5, we would still get 2/5. This makes the decimal 0.4 and the fraction 4/10 equivalent to each other, meaning that they both have the same exact value. But B shows something completely different. 0.2 times 4 equals 2 times 0.1 times 4. But what are they trying to say here? Good question. What they're trying to say here is that any decimal less than 1 times any whole number simply equals the numbers that you could multiply by to get the decimal that is less than 1 and multiply that by any whole number. 0.2 times 4 equals 2 times 0.1 times 4, because 2 times 0.1 is 0.2. That means that 0.2 divided by 0.1 must be 2, because 2 times 0.1 is 0.2. 2 times 0.1 times 4 equals 2 times 0.4, because 0.1 times 4 equals 0.4, which makes 0.8. So in this case, 0.2 times 4 simply equals 4 divided by 10 times 2. Yes! You could also do the same thing here. 2/10 times 4 equals 2 times 1/10 times 4. That makes 2 times 4/10, which adds up to 8/10, because 2 times 4 is 8. And you do not multiply the 10 by anything, so it stays 8/10. So 2/10 times 4 also equals 4 divided by 10 times 2. This makes 0.8 and 8/10 equivalent to each other, or having the same value. Example 2 shows rectangle models to better understand how to multiply any fraction or decimal less than 1 by any whole number. Remember, any whole number can be written as a fraction as long as it has a denominator of 1. So 4 basically equals 4 over 1, because 4 divided by 1 is 4, making W equals W over 1 true, because W divided by 1 is W. We could substitute W for any number. Let's say that W is 5. Then 5 equals 5 over 1, because 5 divided by 1 is 5. Yes, and plus, if we look carefully here, W divided by 1 is W, but 1 times W is W, because 1 times anything is just that thing. So 1 times W is not 1W, it's simply just W. So this is correct as well. A is a pretty good example. These show D and W the formulas for multiplying such fractions together. 1 over D times W equals 1 over D times W over 1. Remember, W equals W over 1. So that makes the statement 1 over D times W equals 1 over D times W over 1 a true statement, because W divided by 1 is W. That makes it so that one of the fractions has a numerator that is an equation and the denominator that is an equation. Wait a second. Equations can be numerators and denominators? Indeed they can. 1 over D times W over 1 is simply just 1 times W over D times 1. But there are some cases where equations cannot be numerators or denominators, so watch out for those. That makes W over D, because W stands for the numerator and D stands for the denominator. So in this case, 1 over D times W over 1. Well, you simply just multiply 1 and W together and D and 1 together, right? Yeah. So we simply just substitute the multiplication that we did here and make it into one whole fraction. 1 over D times W over 1 equals 1 times W over D times 1, which is W over D, because 1 times W is W, and D times 1 is D. This means that W divided by W must equal 1, and D divided by 1 must equal D. Oh, I get it. What if we substitute numbers for D and W? Let's say D equals 3 and W equals 4. 1/3 times 4. Well, in that case, remember, W equals W over 1. So we'll do the same thing for the 4. 1/3 times 4 equals 1/3 times 4 over 1, or 4 wholes. This is because 4 divided by 1 is 4. So 1/3 times 4 over 1 is equivalent to 1/3 times 4, because 4 and 4 wholes are equivalent. This makes the fraction equivalent to 1 times 4 over 3 times 1 also, which makes 4/3. And how do we remember that? 1 times 4 is 4, and 3 times 1 is 3. Plus, if we apply the fact that W divided by W must equal 1, and D divided by 1 must equal D, well, this is true as well, because 4 divided by 4 is 1, and 3 divided by 1 is 3. Yes! Multiplication and division are two completely different equations, but you could check to see if the division is right by multiplying them together. So, 1/3 of 4 rectangles. If we were to add all these 1/3s up, 1/3 plus 1/3 plus 1/3 plus 1/3, we would get 4/3, or 1 and 1/3 all together, because 1, 2, 3, 3 over 3 is 1. And 1 more makes 1 and 1/3, because 1 plus 1/3 is 1 and 1/3. 1 and 1/3, obviously. So, adding all these thirds together makes 4/3. Yes, but there is also another example in which you could do it. B indicates that you do not need to completely simplify the fraction. you could leave the numerator as the equation, but leave the decimal as a whole number. For example, n over d times w equals n over d times w over 1. That would equal n times w over d times 1. N times w equals itself, right? So it stays there. But d times 1 is d, because d divided by 1 is d. So this is equivalent to this. So the numerator could stay as an equation. Now let's substitute the n. Let's say d is 3, w is 4, and n is 2. In that case, 2/3 times 4 would equal 2/3 times 4 over 1, because 4 over 1 is 4, thanks to this equation we saw earlier. And 4 over 1 times 2/3 would make it so that 2 times 4 over 3 times 1 is equivalent to 2/3 times 4 over 1. That makes 8/3 directly, because 2 times 4 over 3 makes 8/3, and 4 times 2 is 8. So we could simplify this one too. So 2/3 of 4 rectangles is 8/3. If we think about it, 4 times 2 is 8. So if we add all the 2/3, 2/3 plus 2/3 is 4/3, plus 2/3 is 6/3, which is 2 exactly. Plus 2/3 equals 2 and 2/3, because 2 plus 2/3 is 2 and 2/3. I feel like I'm saying birds now. Very, very funny word, thirds. So this is 8/3, because it's double the amount of this. So, yep, 8/3 or 2 and 2/3 is the answer. Yes! Now, there is one more example, C, that indicates that you could switch equation B around, and that you could multiply any whole number by any fraction less than 1, instead of multiplying any fraction less than 1 by any whole number. So we're just switching it around. W times n over d equals w times n over 1 times d, because w over 1 is w, and n over d is obviously n over d. So w over 1 times n over d is w times n over 1 times d. That makes it so that it's equivalent to w times n over d, or simply wn over d, because w times n is wn. Making this n times w equal to nw, because n times w is nw. So, yep, nw, wn, same thing. Because if we look here, 4 times 2/3 equals 4 wholes times 2/3. That still equals 4 times 2 over 1 times 3, which is equivalent to 2 times 4 over 3 times 1. This means that the answers to both of these problems must be 8/3, because 2 times 4 over 3 times 1 is equivalent to 4 times 2 over 1 times 3. This makes them equivalent fractions, which means that these 8/3 and 8/3 must also be equivalent fractions, because 4 groups of 2/3 and 2/3 of 4 rectangles all added together equals 8/3, the same exact value. Yes! So these are equivalent fractions. Multiplying a number n by a fraction less than 1 produces a product less than n, because only part of n is being taken. And, after all, kids, part of n is less than 1, because we're only taking one certain part of one whole. So, n is technically, well, it could be greater than 1. But, in this case, when comparing it to the fraction, 4 times 2 is 8, 8/3. Yes. So, only part of n is being taken. This means that only part of 2/3 is being taken. Because if we look here, 4 wholes times 2/3 equals 4 times 2 over 1 times 3, which equals 8/3. That represents only one part of n being taken. So, the product is less than n. So the product is less than 2. And that's true, because as we could see here, let's double check. Let's see if this is absolutely true, because sometimes it could be wrong. 4 times 2/3, n is 2, remember. 4 over 1 times 2 over 3 equals 4 times 2 over 1 times 3, which equals 8/3. Now, 8/3. 8/3 is equivalent to 2 and 2/3. 2 and 2/3 is 2/3 greater than 2. So, it is not always true, but it could be true. Yes, because 2/3 is less than 8/3. So, it could sometimes be true, but the product will not always be less than n. Because more parts of n might be taken, but only one part is taken in this case. So, although it may not make sense because 2 and 2/3 is greater than 2 after all, it is basically, 2/3 is basically less than 2 and 2/3, because it's 2 more than 2/3. So, in some or most cases, the product will be less than n, but in some cases, it will be greater. But we are not going to talk about if it's going to be greater, because that must involve multiplying by fractions and decimals greater than 1, and we're not going to multiply such numbers together. So, we are not going to do that. Yes, although it is a very complicated concept, it will still help you to learn how multiplying by fractions and decimals less than 1 could help you see the reason why the answer is expressed as a fraction and not as a repeating decimal or a decimal in general or a mixed number, because we are just taking the numbers that we multiply by and making it into a whole new number, or a fraction, or a decimal, or a mixed number. So, 8/3 must be an improper fraction, because 8 is greater than 3, and improper fractions are fractions that have a numerator greater than the denominator, and 8 is greater than 3. So this is an improper fraction. All right. That's it from us today. I hope you enjoyed this informational and educational video about fractions and decimals less than 1 and how we could multiply them to apply those facts in daily life. Multiplying such numbers together is a bit of a challenge, but once you get the hang of it, it might not really be that hard after all. So continue to solve math mysteries. Bye, everyone. Bye. Hey, wait for me.